let's see what is the chemical cell without transparence. For chemical cell without transparence, this cell can be constructed by selecting two such electrodes, that is anode and cathode, and electrolytic solution such that one of the electrode is reversible to cation of the electrolytic solution and another electrode is reversible to anion of the electrolytic solution. For example, consider this cell. In this cell, we have selected hydrogen gas electrode as a anode and AgAgCl electrode as a cathode. Right here, in platinum electrode or in hydrogen gas electrode, hydrogen gas gives H plus ion to the solution, which is reversible to cation of the solution, that is H plus ion of HCl solution, and AgAgCl electrode gives Cl minus electrons, or that Cl minus are reversible to anion, that is Cl minus of HCl. Because of this fact, electrodes are immersed in directly acid solution to constitute a cell without transparency. This is the cell representation of this electrochemical cell, that is negative electrode at left side, platinum, single vertical line, hydrogen gas. Hydrogen is present in gaseous state which is having particular pressure. Therefore, I write here gas and pressure in bracket. Again, single vertical line means this hydrogen gas electrode is dipped in HCl solution, and this is AgAgCl in Ag plus electrode. Okay, this is positive electrode and this is negative electrode. Negative electrode always should be right at left direction and positive electrode should be right on right direction. Now let's see what are the reactions of this electrochemical cell. At left side direction means this direction, at negative electrode, reaction will be here hydrogen gas electrode, means this hydrogen gas electrode will give H plus ions to the electrolytic solution. Okay, means 1/2 of H2 molecule is required to prepare 1 mole of H plus ion. Therefore, I use here 1/2 of H2 molecule gives H plus of electrolytic solution, that is H plus electron. Okay, this is the oxidation reaction which is occur at left side direction, and at right side direction reaction will be that AgCl will give this electron and converts into Ag in solid state plus Cl minus ion, which is present in aqueous form, and this is the reduction reaction, that is gain of electron, that AgAgCl acquire that electron. Therefore, this is reduction reaction and this H2 molecule gives an electron, therefore it is an oxidation state. Now let's see what will be the overall reaction of this cell. Overall reaction means summation of all reactions, means summation of components of left side direction and the summation of all components of right side direction. Let's see what will be the overall reaction of this reaction, that is 1/2 of H2 plus AgCl, that AgCl, and plus electron, means all terms which are left side of this arrow are gathered here and all the terms which are right side of the arrow will gather here, means here H plus in aqueous form plus electron plus Ag in solid state plus Cl minus in aqueous state. Now these electron will get cancelled with this electron is left side of arrow and this electron is right side of the arrow, means overall reaction can be write as 1/2 of H2 plus AgCl in solid state gives here Ag in solid state plus this H plus in aqueous and Cl minus in aqueous, means HCl in aqueous form. So overall reaction can be right in this form. Now let's see what will be the reaction quotient for this reaction. Reaction quotient means the ratio of activity of product divided by activity of reactant. So this is the overall reaction. So reaction quotient will be QA is equal to activity of Ag plus activity of HCl divided by activity of AgCl into pressure of H2 gas, right? See here, reaction quotient is activity of Ag into activity of HCl divided by pressure on hydrogen gas into activity of AgCl. And activity of pure metal and activity of metal salt, that is activity of Ag and activity of AgCl, is always unit. Therefore reaction quotient will be activity of HCl divided by pressure on hydrogen gas, right? Now let's see what will be the EMF of the cell. Now let EMF of the cell can be derived as is the difference between EMF of right side electrode minus EMF of left side electrode. Okay, and here right side electrode is AgCl and left side electrode is hydrogen gas electrode. Therefore, the difference between EMF of AgCl and EMF of hydrogen will use the EMF of total cell. Okay, so according to Nernst equation, we can calculate this EMF of the cell. That is, Nernst equation is EC is equal to e power C minus 2.303 RT upon NF into log of activity coefficient. Okay, now let's see one by one. EMF of hydrogen gas EMF of left side electrode, that is EC is equal to EMF of left side, that is EMF of hydrogen gas electrode, is equal to e power of hydrogen gas electrode, means EMF of hydrogen gas electrode in pure state minus 2.303 RT upon NF. Here one electron it gives, means one electron is transferred from left direction to right direction at a time. We should be replace this N by 1. Okay, means 2.303 RT upon F into log pressure on hydrogen gas divided by activity of HCl. Let's see what is the EMF of AgCl, means EMF of right side electrode. EMF of AgCl is equal to EMF of AgCl electrode in pure state minus 2.303 RT upon F into log of activity of product divided by activity of reactant. Activity of product is activity of Ag into activity of Cl minus ion divided by activity of this AgCl. Again, see here in this reaction quotient, activity of Ag and activity of AgCl is 1. Therefore, only activity of Cl minus is remain. EMF of AgCl is equal to EMF of AgCl in pure state minus 2.303 RT upon F into log of activity of Cl minus ion. Now let's see what is the EMF of cell. EMF of the cell is the difference between EMF of right side electrode minus EMF of left side electrode, means EMF of AgCl minus EMF of hydrogen gas electrode. Okay, and the EMF of AgCl electrode is this, that is e power of AgCl minus 2.303 RT upon F into log of activity of Cl minus ion minus EMF of hydrogen gas electrode, means e power of hydrogen gas, means EMF of hydrogen gas in pure state minus 2.303 RT upon F into log of pressure on hydrogen gas divided by activity of H plus. Okay, by simplifying this relation we can write here EMF of AgCl in pure state minus EMF of hydrogen gas in pure state minus 2.303 RT upon F into activity of Cl minus ion minus, means again here we can write minus of 2.303 RT upon F into log of pressure on hydrogen gas divided by activity of H plus ion. This relation can be written as EMF of AgCl in pure state minus 2.303 RT upon F. Here EMF of hydrogen gas electrode in pure state is 0 volt. Okay, and that point we have already discussed in the electrochemical cell. According to electrochemical series, EMF of hydrogen gas in pure state is 0. Therefore, EMF of AgCl only remain in this term. Okay, means EMF of AgCl minus 2.303 RT upon F, which is common in both terms, into log of activity of Cl minus ion plus log of activity of H plus ion divided by pressure on hydrogen gas. By simplifying this relation, we can write here this is the log of activity of Cl minus ion plus log of activity of H plus ion, means we can write as log of activity of HCl divided by pressure on hydrogen gas. That is EMF of AgCl in pure state minus 2.303 RT upon F into log of activity of HCl divided by pressure on hydrogen gas. Now EMF of the cell is depends on the activity of HCl. See here, EMF of the cell is depends on activity of HCl and pressure of H2 gas, and if pressure of H2 gas is 1 atmosphere, then this relation will convert into EMF of AgAgCl in pure state minus 2.303 RT upon F into log to the base 10 of activity of HCl. This term, that is EMF of the cell, is depends on the EMF of AgAgCl electrode, because EMF of hydrogen gas electrode is a 0, and this relation will only EC power is equal to EC EMF of AgAgCl in pure state. Means EMF of the cell which is without transference, it depends on the EMF of positive electrode.